This conference will now be recorded.
Thank you, everybody, for joining us on this presentation from Tim Brewer. Tim is the COO at Synthetik with over 18 years experience in the computational modeling and R&D effort, including artificial intelligence and machine learning. Today, we're gonna talk about how technology is driving business transformation, and it's really a case study that Tim will talk about it from his perspective. Tim.
Perfect. Thanks so much, Luca, and thanks everyone for attending and for tuning in to the webinar. I'll just take control of the and Luca, can you confirm that you can see the slide?
I can see the slide. I confirm.
Excellent. Excellent. Thank you. Let's move this out of the way so I can see what's going on. Okay, so as Luca says, the title of my the webinar presentation today is How Technology is Driving Business Transformation. And I said case study singular on the slide there, but we're actually going to look at three. Some of that's to kind of maybe break up the session, but really I think that they're useful because they give you maybe a different perspective on this topic that we're covering today. So the background, or maybe the hypothesis that I think we'll be working through is that technology has shaped the current business environment, and there is now a requirement to be disruptive, and I've used quotes around that word disruptive there. It's certainly thrown around a lot in this particular day and age that we live. But I also think that the disruptive and maybe transformation or business transformation are not words that sit easily together. And I think that most people trying to transform anything would hope that the process or maybe the outcome is not too disruptive in what they're trying to achieve. So I'll dig into maybe the paradox there throughout the presentation. I'll also talk at some length, and this is from my own personal experience, at how the traditional cost paradigms for hardware and software have gone or certainly disappearing. And now this has changed or is changing. How do businesses stay profitable, and how does this render sort of traditional business models obsolete? And how do businesses or young businesses or startups in particular deal with this moving forward? And then the final component is going to be data, and data will come up through much of the presentation. I don't think that'll be a surprise to anybody from a startup. But how data is driving artificial intelligence, the risks and opportunities of that. And as I say, I'll be using those case studies to look at successes, reticence to change, requirements for validation and verification, so V&V, that all must get wrapped into that business transformation process. So this is going to be kind of the golden thread, and perhaps we'll revisit this at the end of the presentation when we sum up in the closing remarks. But first of all, I think it's important to give an introduction to myself, really, so you know where I'm coming from. I certainly don't purport to be, the global authority on business transformation and technology, but I think and I hope I can provide some useful insight to where I come from. So I'll provide kind of a little bit on my personal background, the context. Despite the English accent, I'm speaking to you from Austin, Texas today. And I feel that this will be a US-centric look at technology and business transformation from a technology startup and a small business owner such as myself. The case studies I've chosen or selected span fairly diverse industries. So we look at the insurance, the engineering/environmental, and then the security industry. So again, I've tried to pick from as broad a perspective as I can to kind of draw those lessons and show they're not just single lessons from single industries. And I'll also provide an introduction to the case studies so you kind of warmed up to when we talk about them later on. So a little bit about myself. So my name is Tim Brewer. I'm the Chief Operating Officer at Synthetik Applied Technologies. And we are a technology startup that was founded in 2017. And we're headquartered in Austin, Texas. And for those of you who've never been to Austin or never heard about kind of the technology scene that is really booming here at the moment, I think it's definitely worth a visit, and certainly, you know, I'd be happy to facilitate that visit and show you around. But there are numerous technology incubators and accelerators. The Army Futures Command, which is a 3-star Army command focused just on technology for the Department of Defense, has moved here. We have AFWorks, which is the Air Force startup. And then we have the Defense Innovation Unit, who are also in Austin. So there's a huge amount of technology focus within Austin and the tech community in Texas. And that's the kind of ecosystem that we're currently operating within. We're partnered as a company with the Texas Advanced Computing Center, or TAC, and this gives us access to some of the world's most powerful computing resources, and you'll see some of those used in anger later on in the presentation. We're a member or grantee of the Microsoft AI for Earth community, which gives us access to some fantastic resources from Microsoft and really links us into, as I say, that community and that body of knowledge that people are developing as regards to using technology or leveraging technology for the betterment of the world. We conduct applied research and development with international commercial customers, but also we do a lot of work for the US federal government. And then we also provide consulting services as kind of an add-on or a follow-on to the R&D work that we're conducting. So I hope that gives you just a bit of context. I provide that more so you know where I'm coming from in the comments that I'm going to make. But I hope you can see that really small business, technology startup, and fairly young and in a fairly active part of the world in terms of technology development. Now, the case studies I'm going to talk through from top to bottom. The first one, case study 1, I've entitled that The Employment of Artificial Intelligence to Protect Marine Species. And this is a project that we're currently conducting for the National Oceanic and Atmospheric Administration, or NOAA. And here we're developing a technology solution for cameras, AI-enabled cameras, both above and below the waterline. Principally, these are going to be around offshore aquaculture facilities, so basically large offshore fish farms. And here, the aim of this technology is to identify endangered marine species before they become entangled. And I'm sure many of you have seen the news. There are increasing case studies of these large marine mammals getting caught. And unfortunately, because we aren't monitoring them in real time, they'll be there for maybe days or weeks before they're discovered. And tragically, it's too late by that time. So that is the technology, the solution we're working with for NOAA in case study 1. In case study 2, we move to something completely different. And here we're employing artificial intelligence again, but here it's to support security screening. And as this project, we're working with the Transportation Security Agency to generate synthetic data. So not real bags from the real world, but models that we've generated computationally or threats that we've inserted into bags that weren't there before. So synthetic data generation, and also looking at 2-dimensional and 3-dimensional machine learning models. So that's case study 2. And then finally, some work that Luca and I have focused on before, which is looking at protective design. So looking at Synthetik's open source, our blast foam air blast software, or air blast code, which is a free and open source computational fluid dynamics code that's used to model high explosive or detonation events. So a bit of a key in the title there is open source. As I said at the start in my opening remarks, we'll be looking at how free and open source can work for technology companies when traditional business models would say that if you're giving something away, it's very hard to make money off it. So we'll be coming back to that with case study 3. So I hope that provides just a brief introduction to the case studies. And as I say, we'll be drilling into those in each part of the sections. So the format, I've split this down really into 3 parts with a case study introduced at the end of each part. And I'll admit up front, this handrails an MIT course that's currently being developed, which actually deals exactly with the topic that I'm talking about today, which is technology and business transformation. And the 3 sections I've selected are minds and machines, or how artificial intelligence and data can drive that business transformation process. Products and platforms, which looks at the future state of hardware and software. And this goes back to that traditional paradigm I've said, where before it used to be very much selling hardware, selling software, or selling integrated hardware software solutions. And I do feel that we're moving away from that now, and that requires some different thinking in terms of business models. And finally, the core and the crowd, which is focused on the decentralization of knowledge. And I think that the rise of free and open source platforms and how that's maybe being inculcated across academia and other parts of industry will be the final point that I come to. So that's the three sections that we're going to come to. And as I say, I'll break each of those up with a little look at a case study, which I hope reinforces the point that I'm looking to make. So first of all, minds and machines, and specifically artificial intelligence and data. So I think certainly from the industry that I'm working in here in Austin, I think, and many of you will have been exposed to this as well, that the great arrival of AI and ML arrived with an extreme, welcomed up. It was going to be the panacea. It was going to solve everyone's problems. And I think very quickly that bubble burst. And I think now we are much more back to the realistic and judicious application of AI and ML in areas where it can actually assist and actually have real credible results. So I think from our use of it, other than maybe identifying cats and dogs in images from a Google search, I think really we found the most effective application being in areas or industries where people have a lot of data, but most people have a lot of data. But I think people who have a lot of data, who own the data, who can therefore get around kind of privacy requirements that are very present in the US, as I know they are in Europe and the UK, but also have an ability to effectively pre-process that data, or in ML speak, to kind of annotate that data to indicate to the machine learning model what is of interest and what am I trying to do. And that annotation process or pre-processing step is very frequently quite labor intensive, hence it's often offshored, but it does require a great deal of work up front, and therefore it needs to be done. It's an essential step in really the effective application. So I think rather than AI being everywhere and all things to all people, I think pretty quickly it's narrowed down to people who own their own data and have ability to pre-process that data themselves. And I think that's where we've seen the greatest amount of work in this area, and really effective work in this area. The other key thing, and everybody's worked with AI and ML will know that the data is key, data is king, and certainly the value of data is destabilizing traditional technology business models, because everything is becoming data-centric, to use another sort of key buzzword of the moment. So all value now is really moving towards the data. It's much less about how you're capturing it or the equipment that you're capturing it on or where you're storing it. It's all about that new data. And I've heard it be called, data is the new oil, the new black gold. And we certainly see that more and more. And as I say, business models, business agreements are certainly focusing on that data-centric component. And that really introduces the fourth bullet, which is the rise of synthetic data as a means to augment real data sets. So I've already described the complexities and the difficulties of obtaining real data, the privacy concerns that might go along with that. But the fact now that we're able to generate data synthetically to augment those real data sets or based off those real data sets is a massive force multiplier. And again, speak to the previous bullet, if there's value in real data, then there sure is value in synthetic data as well. So again, that's been another area for considerable growth. But there are some downsides to this, even in terms of a data-centric industry. Security concerns are certainly one of them, especially if people are dealing with sensitive data. And if you speak to companies, most companies' data is sensitive. As I've already said, annotation or pre-processing of this data is labor intensive. And as a result of that, in the last 5 or 6 years, a lot of that has moved to being offshored. So they'll send that overseas to be annotated and then sent back once that data is ready. But certainly within the last 12 or 18 months, as kind of federal agencies have got more involved here in the United States, there has been an increasing reticence from companies to do that. And now offering data annotation as onshore in the continental United States is really being seen as a value add. So the value of that secure annotation and secure data handling is now outweighing the potentially cheaper or more low cost offshore annotation opportunities or services out there. So that's been quite compelling over the last, let's say, 12 to 18 months, and I can only see it growing. Privacy concerns is another one, and has really stymied a lot of work that people would like to do. So certainly individual privacy rights in terms of collecting data on people. This happens all the time on our browsers and on our cell phones. But for smaller companies such as tech startups like ourselves, that becomes a very, very large issue. And certainly the legal ramifications of getting it wrong are probably or almost definitely terminal. So again, that is slightly stymieing this process as well. And then layering on top of that, or I think interconnected, is kind of regulatory pressures. So NIST here in the United States are certainly releasing guidance and are becoming more active in the enforcement of that. And I think that there's more international political scrutiny. You've seen this from the likes of Facebooks and TikToks of the world. And I think this is equally applicable to kind of the young startup community, albeit we're less able to defend ourselves than maybe those larger companies that I mentioned. So again, lots going on. And I think that kind of covers that minds and machines and where we're going and potentially the implications for business transformation. But as I said, I wanted to go to a case study to really draw out those points in more detail. So as I said, this is going back to our work with NOAA in identifying endangered marine species in the water, both above and below the waterline. And just to go through maybe some problems or some issues that were relevant to that particular research. So first of all, a paucity of suitable data. We didn't have enough data, and I think that is the same for everybody in all walks of life if they're trying to do anything with AI or ML. NOAA had a large database of imagery related to these whales, relatively large, about 25,000 images. Of course, none of them have been annotated, so it might be a picture of a whale, but it certainly doesn't indicate in the picture where the whale is or what type of whale it is. So that is a key issue that needs to be wrestled with as we move through these problems. The incentives to enhance detection, and I'll contrast this with the security work we look at later, are threefold in this case. The environmental impact, so trying to save whales is a good thing, or endangered species. The drive of legislative requirements, so if you're opening an offshore aquaculture facility, you must do this. And then finally, from a commercial aspect, the last thing that you'd want at your large offshore aquaculture facility is to have North Atlantic right whale caught within that particular facility, because it's going to take it offline, it's going to damage it, and potentially the reputational damage to you and your brand might be irreparable. So there's certainly incentives to leverage AI from a business perspective. Typically, ML models, once they're implemented, are proprietary, and this is another issue. Anybody working on a Kaggle competition or any other kind of endeavor like that, can find lots of ML models to pick off the shelf. But once they're integrated within a technology, for example, a GIS technology, they do become black boxes and therefore less accessible to businesses who want to come alongside the large providers and try and add benefit and carve out a business model in that area. So that is challenging. And the other thing that's challenging is it's very difficult to conduct a kind of apples to apples comparison against what they're providing, what within those machine learning models. And again, that provides a real challenge if you're trying to develop a compelling business case around that. The other point, and I'll come on to this in the next section as well, is the move towards zero cost or disposable hardware and the implications on that on business transformation and business models. So in this example here, you can imagine if we're capturing imagery offshore, they're pretty robust, the cameras. They need to be if they can operate in that environment. But the real value, as I said earlier in the briefing, is focused on data. Like the real value is the data, less so on the hardware. And therefore, a move towards providing the hardware at zero cost and just retaining ownership of the data is becoming, I think, really the standard go-to business model for companies who are in this imaging sector. So again, I think that is being really transformational in this way. Open data formats certainly help, and that's something that a number of organizations are pushing. We'll come onto that in sort of section 3 of this. But again, there are security concerns, even when trying to do something as obviously good for the betterment of the world as trying to protect endangered marine species. And as you can imagine, if you're good at identifying grey things under the water in the open sea, like a whale, you can imagine that some people who also have grey things under the water, like the Navy with submarines, might also be a little bit interested in what you're doing, and therefore want to ensure that you're not disclosing or tracking anything that they don't want you to be. So again, there are interesting privacy and security concerns that come in even when you're doing something as good for the world as tracking whales. So that really covers off that case study. Moving on to the second section, and I call this products and platforms, which is looking at the future state of hardware and software. And I think that the first point is not meant to be a negative, but it does look like Moore's law is kind of petering out or coming to an end. And those of you who aren't familiar, this is the rule that every 2 years, the number of transistors on a chip would double. As you can imagine, the scale now that we're operating on is now down to pretty much the visible, what's possible from a visible perspective in terms of the size of chips. But that is coming to an end, but albeit we're still seeing huge growth in algorithms, in software, and also the advent of more specialized chips, and the graphical processing units, or GPUs, has been a game changer, and firms like NVIDIA are kind of now penetrating a number of different areas with the potential speed ups that porting code to run from CPUs onto GPUs is now offering. There are also low cost, zero cost, and open source business models that go with it. I've referred to kind of the disposable hardware on the previous case study, and this is certainly true across multiple business areas, whereby people are looking or really demanding open source business models. The Department of Defense and US government is a great example of this, where now they're no longer happy to license technology from kind of tier 1 vendors that they've been doing for the last 50 or 60 years. And they're now really waking up to the advent of open source models because of the benefits they bring. And I'll come on to some of those in a little later. And then finally, is this driven by technology or as a consequence of the technology environment? And I think this is something that I wrestled with while pulling together these slides. I mentioned at the start this desire or drive to be disruptive, and I think that is true, and I think people are trying to look at new ways to offer value and benefit. So I do think it is a consequence of the technology and the environment, but also I think the technology is facilitating this because it is so low cost. I mean, much of our hardware purchases are done on Amazon or kind of other commercial marketplaces. It's very rare now that we need to go out and spend tens or hundreds of thousands of dollars on a piece of imaging equipment or sensing equipment. So I think it's both. I think that both the technology is facilitating this, but I think this kind of tech, fast-moving environment that we're now living in is also driving this move to a new business model for hardware and software. And again, I kind of want to go over that in more detail in a case study. So moving away from the whales and onto spotting prohibited and illicit items within your luggage when you're traveling. And on the top image there, you can see just a very basic machine learning model for a pistol with some synthetically generated data. And on the bottom, you'll see again some synthetically generated data. On the first spin, you'll note the box has nothing in it. When it comes around again, you'll see that we've inserted a knife. And when it comes around again, you'll see that we've inserted a pistol. So this is really a hybrid of both real data that's been captured, but also synthetic data that has been inserted. And this is for training AI and ML models. So again, the first bullet is exactly the same as the one we went over before, which is a paucity or a shortage of suitable data to conduct this. And again, even an organization like the Transportation Security Administration here in the United States, they have lots of data. They collect, there's millions of passengers a day, or there certainly was pre-COVID, but none of that data is annotated. The model doesn't know in the image in the top right there where the hairdryer is. It doesn't know where the shoes are, the glasses, the pistol, the high heel shoe, the headphones. It doesn't know what they are, and that model needs to be informed as to where those items are located, and that's where that pre-processing and data annotation comes in. Again, I really want to get to the business. So what's driving the desire to enhance detection? It may seem obvious, but it's really threefold. First of all, to increase throughput, so the volume of passengers, because it's good for the economy, having people traveling, and driving, making sales. And that's twofold. One, to reduce false positives. So, they think they found something when actually they haven't. Or secondly, to reduce the requirement for pat downs, because having a pat down slows the process down. Nobody likes being touched. So I think that's really twofold. The second thing is to reduce security officer fatigue and the degradation of their effectiveness. So making the models more automated and allowing them to relax and maybe do their job more effectively. And then finally, the most obvious one is to improve the security of traveling by whatever mode of transport you're traveling by. But again, as before, ML models are typically proprietary in this space, and certainly in the security screening space are owned by equipment manufacturers or OEMs, and they're typically, therefore, they are black boxes, so difficult to see the source code or see the layers or the network architecture. So very difficult to conduct apples to apples comparisons to, and therefore, as a small business, very difficult to add additional value in this space. So again, another thing that is, I guess, driving how businesses interact. Open data formats, again, are helping. Data security concerns that I mentioned in the drive to offshore annotation services, that is, if not allowed, shortly will not be allowed. So I can see more and more of that coming onshore, and more value placed on the ability for firms to provide adequate data security, and less on their ability to do this for cents per image. And again, the privacy concerns. So whenever they're imaging passengers, they're not allowed to show what that scan looks like to the TSO directly in front of them, and that offers some really challenging issues in terms of relating where the threat or the perceived threat on a passenger is, and then how it's presented to the TSO conducting the check. So I hope a very different case study to the first, where we were looking at identifying endangered marine mammals, but I think you can see the number of the lessons are very similar in terms of how the technology is driving or affecting how the business is conducted in this particular industry. And then the final of these three areas is going to focus on core and the crowd, or the decentralization of knowledge. And I think that I guess the hypothesis here is that the crowd, so a decentralized knowledge, outperforms a more centralized model, i.e. having data out there and distributed is more favorable than having it locked up in the center with limited number of access. Now, I think it's very obvious, or you can immediately draw concerns from a business perspective, where most businesses that I've been aware of like to keep their IP and their proprietary information very much in a centralized core under lock and key and protected by NDAs or however else they want to do that, rather than just pushing it out and decentralizing everything they know. And I do think this is having real implications. We'll come on to this later in terms of organizational structures, but also how companies think about data and how they think about how they're interacting with their customers, because the customers' requirements and aspirations are changing in terms of how they interact with this. And this is driven by the second bullet, which is data accessibility. I think we can all agree we live in a time that data has never ever been more accessible, in seconds, microseconds. Storage, you can buy huge amounts of storage for very little, and transfer rates for data are extremely quick as we come onto 5G or fiber optics or any other data transfer mechanism. So that is really affecting the public and their perception of how data should be stored, handled, and how available it should be to them. And I think that conversely is then putting pressure on businesses to meet that requirement. I also think there's a generational change or generational attitude change, that what may have been 10 to 15 years ago, it would be unthinkable to expose or maybe promulgate your company's sensitive information or information on what they're doing. I think now with with a new generation coming into the workforce, I think that those attitudes are very much changing, and people now expect that information to be at hand. And I think the initial reticence towards moving towards maybe open source models or data sharing models is now, we're really getting some momentum behind them. And I think that's really linked to a generational approach to that. But it also has implications, I feel, on how organizations are structured, or certainly how organizational structures relate to how data is now laid out across the company. And this, from a small firm, has implications. So where your data is stored and who has access to it. And then also, if you're pushing this out openly and it's changing, and we'll come onto this in our case study, how we manage that change and how we organize that within whatever structure we're using in terms of responsibilities of staff. So I do think that this decentralization of knowledge is going to have, or is having, profound effect on business organizations and organizational structures. And really, to come onto that, we'll use the last case study, which is looking at our own open source blast foam software. On the right hand side, you can see some images from Beirut, where we were modeling that tragic event on the 4th of August, where you can see the explosive event, then you can see the shock propagating out from by the grain silos. And in the bottom right, you can see some outputs from the model, where you can see the amount of damage that has been imparted to the structures in and around the seat of the explosion. So we felt, and this is quite a personal story, we felt, and I've been in this industry for nearly 20 years now, that first of all, the industry is changing rapidly. Engineering industry is, I think many industries are changing very rapidly. And I also felt that the software that supports that industry is changing very rapidly. And I think that the move to kind of free and open source models was always going to happen. Kind of the engineer's spreadsheet has always been a thing in the industry, and has changed hands, and everybody wants access to it. And I think more complex software like blast foam very much follows along with that. So people were demanding or wanted to be better served by their software. And I think that the free and open source model is really becoming what people want to see, mainly because it's free. Like, free is good, you don't have to pay for it. But also because free and open source means that as an engineer, you can have ready access to the source code, so it's visible to you, and that obviously gives you more confidence. You, an engineer who often has a license requirement to stamp drawings or sign documents, that you are happy with what a piece of software is doing and how it is doing it. So that confidence and the ability to validate and verify what you're seeing is extremely important. But of course, being free and open source, it might be great for the engineer, but it does introduce interesting challenges for the business. So how do we make money from something that giving away, and that everybody can see, and indeed, depending on what license you're using, like a GPL license, people can just take it and create their own version of it. And I think for us, the focus of this has been, rather than being we're selling the most or we're generating the most revenue from sales of software, I think the focus is moving more to leading, or that rather overused word of influencing or becoming an influencer, rather than ownership. And I do think that because of kind of the generational approach to kind of knowledge that I spoke about on the previous slide, I do think that this is where real value is built and where I think a real business can be built. And certainly, despite the fact that we give away BlastPhone for free, and it is open source and anybody can see to it, that doesn't mean that it's not a very viable income and revenue stream for us, just because I think it puts us at the forefront of that industry, and then allows us to have sort of downstream conversations with people about the code, about extension, about what it's doing. So I do think, even though it's free, it can still be a viable business model. The other good thing about it, in terms of that distributed knowledge, is the user and developer community. So now our active users are all effectively developers, because they all have access to exactly the same source code that we do. They can spot bugs. They can, if something isn't behaving as it should in the code, if they want to extend the code and then push that extension back to source, then that's good for everybody. The community benefits as a result of that. And I think that kind of community-driven spirit and community-driven development is becoming increasingly powerful. And I think more than that, it is what, in our industry, is what engineers are now demanding. Now, that wasn't to say that it was always an easy ride, and certainly we do get questions, rather nonsensical, I would say, when people say, oh, I feel uncomfortable using open source data because how do you know it's right? Which I think is strange, considering, unlike licensed software, open source software is the only one where you can actually get under the hood and take a look and see what it's actually doing. But that doesn't mean that it's not a real concern, and that it does impact how people react to it. But again, I do think that's generationally based, and I think as we move forward, I think people's willingness to pick up free and open source and use free and open source code is going to increase. And I really thank academia for doing that. And I know academia, maybe not in the United States, but globally, is working on pretty meager budgets. So they are looking for options that are free and open source. But I do think that academics globally are really instilling that culture of using free and open source tools, and really driving home the benefits of doing so. And I obviously only hope that that continues, because I think it better serves the engineering community as a whole, if that is the direction that we are moving in. So that kind of brings me to the end of the briefing here, and really just to go over, I think in three areas that we covered: so minds and machines, and then looking at AI and data, and then move towards a sort of data-centric world where the real value is in data, albeit I can see more people moving data processing onshore than pushing it offshore as we move forward. But I can see the real value being there, and I can see that from a business transformation point of view, really driving people to look at business-centric business models, or data-centric business models, sorry, rather than maybe more traditional models that they've used over the last 20 or 30 years. And that really brings us to products and platforms, which is this future state of hardware and software. As the cost of hardware is going down, exponentially, that's my claim, but it's going down very fast, and really becoming, commercial off the shelf is the way to go. And it's really a driving towards potentially, almost disposable hardware, or potential opportunity to give that hardware away for free, and then allowing you to then collect data and then obviously generate the value or benefit from the value of that data that I described in point one. So I think that's an interesting problem from a business transformation point to tackle. And then third, the core and the crowd, or the decentralization of knowledge. I think there's no doubt we're moving towards decentralization. I think our own attitudes towards knowledge is driving that. I think we all expect that, we all have a cell phone in our hand, and knowledge is, only a Siri question or a quick Google search away. So I think that really is permeating our culture, and is therefore permeating the business environment as well. We released the Blast Phone code as free and open source, and I certainly think that kind of leading or influencing that industry is potentially becoming a more preferable mode rather than just pure ownership of codes and software. So where are we heading? I think more of the same, and I think an ever increasing rate of what we've discussed. So I think that data is going to be central to everything that we move as we move forward, and I think that businesses are going to need to transform and change to accept the fact that people want more access, and that the traditional ways that they used to generate revenue from technology is definitely going to change. But what we don't know, we didn't know 18 months ago, 12 months ago that we'd be dealing with a pandemic. Is that changing things? Yes, I think it is. But certainly from our very small part of the world, I think the ability to collect and store and distribute remote data, or data remotely, is even more important than it's ever been. Now we're having to social distance, we're having to conduct business through modes such as I'm talking to you now. And I think the ability to gather that remote data, store that remote data, and then promulgate that data has become even more essential. So if anything, I can see that perhaps accelerating some of the areas that we've discussed during the briefing today. And with that, I'd like to conclude with that. And Luca, over to you if anybody has any questions.
There is a question from Roberto, which asks if free and open source are really AI ML source code available, or they will be available.
Yeah, I think that on the AI ML side, much of it is open source. It transitions between being free and open, I think, as soon as it gets integrated into a product or a platform, and then that whole piece of technology then becomes wrapped in the same intellectual property, and therefore becomes pretty intractable. So I think with me as a researcher, it's great because we can use AI and ML models pretty early, and they are free and open source. But what's more difficult is coming alongside an established industry and trying to penetrate that industry or generate value within that industry, because many of those doors that were open in the early days when you were just dealing with models off the shelf have now gone away, and you're confronted with a black box who nobody is willing to kind of let you see or play with or compare. So I think that's the potential challenge, if that answers the question.
Yes, Roberto has a second question. What could mean decentralization of artificial intelligence? So you spoke about it before. So
yeah, I think that's an excellent question. So I think the decentralization of knowledge with regard to AI is twofold. So one would be, or maybe threefold. One would be the models themselves, and I think groups, larger groups like Facebook and Google are pretty good about pushing them out. They're becoming a little less willing now, especially for their 3D models. I don't know why, but they're pretty good at pushing those to be free and open source. The second would be, once they've trained them on particular data sets, that would be another way to decentralize that knowledge. But again, that's very application specific. There are some instances where you can get pre-trained models and others where you can't. So that would be the second. But I think the thing I'm getting to would be the data. I think if people could release annotated data sets, then I think that would truly decentralize the knowledge in this area. But as I've already said, I think people, and I'd include myself in this statement, really see the value in that data and that is now what they're building their businesses around, is kind of the ownership of that data. So there's going to be, I guess, less willingness to decentralize that particular aspect of it. But yeah, again, I hope that answers the question.
Thank you, Tim. For me, it did answer. I hope it did answer to Roberto and everybody. We're gonna wait another minute or so for anybody else that has any other question. I want to thank Tim. We have worked together in the past, and with some of the simulation that you have seen, and definitely I think that is fascinating, the activity and the work we are doing on the artificial intelligence on my side of the work, on my side of the field, that is toward the last presentation you made, the last slide that you made. I hope that everybody is happy with that. Tim, I want to thank you very much for joining us from Houston. I will take you up for visiting you, not soon, I think, but I will take you up for the visit in Houston when this will be allowed, or if not, I need to be stuck with you for a longer period. So I will make sure I can come back to Switzerland. Thank you, everybody. Thank you for tuning in. Thank you, Tim.
Thank you so much, everybody. Take care. Bye-bye.